Today's episode of the Cloudcast is sponsored by Datadog, a real-time monitoring platform that unifies metrics, traces, and logs into one tightly integrated platform. Datadog APM empowers developer teams to identify anomalies, resolve issues, and improve application performance. Begin collecting stack traces, visualizing them as flame graphs, organizing them into profile types such as CPU, I/O, and more. Teams can search for specific profiles, correlate them with distributed traces, and identify slow or underperforming code for analysis and optimization. Plus, with Datadog APM Live Search, you can perform searches across the full stream of ingested traces generated by your application over the last 15 minutes. Try Datadog APM free with a 14-day trial, and Datadog will send you a free t-shirt. Visit datadog.com/APM-Cloudcast to get started. That's datadog.com/APM-Cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody is doing well. We are getting towards the end of July 2022. I'm getting ahead of myself. And things are still hot. They were hot last week. They're still hot this week. Some crazy, crazy stuff going on. So hope everybody is getting a chance to stay cool where you are, or at least stay safe where you are. I've been doing a couple of the intros here lately. I know Aaron is typically the person doing the intros. He's still getting over some COVID, so take care of yourselves. COVID is still out there. It's starting to rampage again. I know it's hit a number of people that are close to both Aaron and I lately, and luckily they're safe, but it's still out there. So folks, take care of yourself. Stay cool. We are starting to do a little bit of Kubernetes stuff. Last week, or at least Wednesday's show, we did a Kubernetes one. This one, we're going to do another Kubernetes one. And like we mentioned on Wednesday's show, we've covered a lot of the sort of mainstream Kubernetes, what's going on with the project and new updates and so forth. But we're really starting to look at some of the areas in which, we're rounding out how you operate, how you optimize, how you deploy, how you, test and so forth around Kubernetes. And this week is no different. We're going to dive into how do we make sure that we're being effective with our costs, and do it with a new friend of the show and new startup that's making a lot of noise, the folks from Kubecost. So we're going to get to that right after the break. Today's show is sponsored by CloudZero. For software-driven companies focused on growing margins, CloudZero is the only cloud cost intelligence platform that puts engineering in control by connecting technical decisions to business results. By analyzing cloud services like AWS and Snowflake, CloudZero provides real-time cost insights that help you maximize margins. Engineering teams can answer critical questions like, who are my most expensive customers? How much does this specific feature cost our business? What's the cost impact of re-architecting this application? With cost anomaly alerts via Slack, product-specific data views, and granular engineering context that makes it easy to investigate any cost, CloudZero is your complete cloud cost intelligence platform, connecting the dots between high-level trends and individual line items. Join companies like Drift, Rapid7, and SeatGeek by visiting cloudzero.com/cloudcast to get started today. That's cloudzero.com/cloudcast. Today's show is sponsored by Lightstep Incident Response. Built on the ServiceNow platform used by over 6,000 companies worldwide. Lightstep Incident Response allows you to scale your incident response team without adding to your monthly bill. With intelligent on-call scheduling and escalations, you get the full context of your service health. Lightstep Incident Response immediately pinpoints issues and uses machine learning to send group text, reducing your time to respond. And you can seamlessly orchestrate alert and incident triage with on-call scheduling across Slack, Teams, Zoom, desktop, and mobile. So get started today with a free 30-day trial of Lightstep Incident Response by visiting lightstep.com/cloudcast. That's lightstep.com/cloudcast. And get a free t-shirt after your first alert or incident. And we're back. And folks, we seem to be doing a bunch of stuff around Kubernetes these days, which is good, covering a number of shows. Not so much kind of the ins and outs of pods and schedulers and all the underlying infrastructure for Kubernetes, but trying to really kind of look at some of the areas more around how we operate it, how we optimize it, all those types of things. Especially, here in the summer, a lot of folks are starting to think about, hey, KubeCon's coming back to Detroit. We're going to go to KubeCon in the fall and start kind of trying to round out some of the discussions we've been having about Kubernetes. And one of the topics, obviously, that is on a lot of people's mind these days is kind of this intersection between, what's going on in the technology world, but also what's going on in the economy. And the economy obviously affects all of us. And once you start talking about economy, you start talking about costs and how do you optimize things, maximize things, and so forth. And so today I want to dive into a topic that we haven't touched on yet, but is starting to get a lot of buzz. And that's a concept called Kubecost. And so the best people for us to go talk to that about is Webb Brown, who is co-founder and CEO of Kubecost. Webb, welcome to the show. Great to have you on.
So great to be here, Brian. Really, really excited for the chat. Can't wait.
Yeah. Let's talk a little bit about your background. It's an interesting mix. A lot of times we get people who come from a very deep technical background, others who come from, business, finance background. You're kind of unique in that you've got background in both of those, but tell us a little bit about your background, what you were doing before Kubecost, and then ultimately what led you guys to start the project and start the company.
Yeah, absolutely. So before creating the Kubecost open source project, my co-founder and I were both at Google. I was a product manager and he was an infrastructure engineer. And there we were, thinking about a lot of the same problems that we are today around, like optimizing or this relationship between cost, performance, and reliability. Before Google, just like you said, I had kind of a mixed background. I like undergrad, training in engineering, worked on a startup, soon after school, then went to actually grad school where I was more focused in finance. And both of these worlds have always been just like incredibly interesting to me. Now it feels like I'm living my dream and getting to think about kind of both aspects, going deep in technology, whether it's like thinking about application efficiency or infrastructure efficiency, but also thinking about, markets at which you provision and consume resources that, can have a really big impact on your company's, margin or bottom line, if you will.
Yeah, very cool. We've talked on this show in the past a lot about kind of the guts of Kubernetes. So people are pretty familiar with that. One thing I see a lot when various companies run surveys, whether it's a CNCF or others, one side of the equation will sort of say there's more and more people using Kubernetes. It's becoming more popular. There's more applications being used. And then, there's always questions about how do you struggle? Where are some of the areas that you struggle with it? And I'm surprised sometimes to see that cost is one of those areas, mostly because when I think about how people use Kubernetes these days, especially, in 2022 and so forth, a lot of it's, the managed Kubernetes services. It's an EKS and AKS, which, when I look at the cost of those are pretty inexpensive, right, as a cluster. But I continue to hear this sort of, Kubernetes can be expensive, the costs get out of control. Help me fill in the blanks. What am I missing in terms of, if it costs this much to run a cluster, why does cost keep coming up all the time as a challenge with Kubernetes?
Absolutely. And it's really kind of like the fundamental starting point that we work with companies on. And so just for a little bit more context, Kubecost started, right at about 3 years ago. We now work with thousands and thousands of companies to help them like monitor and, optimize Kubernetes and related cloud spend.
Yep.
And it's really twofold. First is technical, and the second is more behavioral or how Kubernetes is commonly used, especially in medium and large enterprises. So the technical piece is if you go back, pre-containers, pre-Kubernetes, the most common way of kind of measuring and or allocating or charging different like product teams or applications across your organization was to kind of go to like a cost and usage report or go to a cloud provider and tag or allocate a particular VM or a particular database or storage bucket, et cetera, to like a team, department, cost center, et cetera. That model largely breaks down with Kubernetes because of the Kubernetes scheduler itself, which is dynamically scheduling things across your environments. So at any given time, you may say that N number of applications are running on this machine, and then fast forward and that number's totally changed and it may be an entirely new set of applications. So there really is kind of no source of truth for this at the cloud provider level, right? So you truly have to peer into and dig into the Kubernetes scheduler to do this like accurately and, like fairly and, in a timely manner. And then secondly is, the beauty of Kubernetes is like it is decentralizing lots of decision making. When most commonly teams will move to a more of a microservice architecture where teams get to make product and engineering decisions on their own, and oftentimes engineers have great ability to ship new services or updates to existing services really quickly. Right. Yeah. So all of a sudden it just is a much harder like governance problem when, you're releasing, more quickly and releasing across various teams or, business units even to actually understand who drove an increase in spend and why, and is that expected or unexpected. So it's really those, twofold that like really need to be tackled to like manage spend effectively. And I would just say, to give the context, like, about 3/4 of our users are on the large like hyperscalers. We actually have a meaningful footprint of our users on-prem. Around 20% of our users are on-prem, and there obviously like it's a different set of decisions that are being made because you have like different levers available in terms of like what you can scale up, scale down, distribute, et cetera.
Right. Yeah, no, that makes a ton of sense. It's and quite honestly, now that you explain it, it makes sense because so much of where the struggles in IT these days tend to fall is on one side, it's, hey, these new technologies are available, but we're treating them like VMs. We treat them sort of like legacy, and we'd like them to be like the new stuff. And then on the other hand, it's like you said, we're getting into these decentralizations of IT doesn't make all the decisions anymore. Now what are the ramifications of that? So yeah, that makes the context of that makes a ton of sense. Let's talk a little bit about the Kubecost project. Give us kind of, obviously we don't have a whiteboard, but kind of give us a technical overview of how it works, how it interacts with your Kubernetes clusters. And then, how do you guys have to think about it in the broader context of the Kubernetes ecosystem? So you have, things like Helm charts and operators and GitOps. And so kind of walk us through some of the technology behind the scenes.
Yeah, absolutely. So I think that's a great, tee up to like the core problem that we're solving, which is when you haven't kind of navigated those technical and, organizational or behavioral, challenges, like cost is truly a black box to a lot of, teams on Kubernetes, right? So they can say, hey, look, I spent, $5 million this past year on compute, but I had no idea what team application, project drove that expense. And so the way the Kubecost project would work is you Helm install, it deploys a single pod that starts listening to data from a number of different data sources, the Kubernetes API, things like cAdvisor to like look at usage data, looking at the like Linux kernel, to actually look at like network traffic, to think about like network egress and ingress costs, like your cloud providers, billing APIs if you're in a cloud environment or like hosted environment. And all of that comes together to in real time start generating like cost metrics about your environment. And so the first part of that is it would give you, visibility by like essentially any dimension. So if you want to think about cost by namespace, label, cluster, pod, and everything in between, like it would be available. You can slice and dice that a bunch of different ways in real time. And then secondly, it would, based on all of those same metrics, start generating insights available to you. So how to actually optimize that spend without compromising performance or health. And then lastly, it would give you like governance solutions on top of it, right? So things like budgets and alerts and recurring reports and policies, et cetera. So all of that is kind of generated like by that kind of core Kubecost pod. It does talk to like we typically ship with a Prometheus today, where Prometheus can be replaced by really kind of like anything that speaks PromQL. So Cortex, Thanos, or otherwise. And that is essentially the underlying time series database. And then the Kubecost application builds all these really dynamic caches so that you can do really powerful queries like, give me, cost by pod over the last 180 days or cost by label over the past year. Because those are, when you're really starting to like look at trends over time, those are oftentimes like very relevant requests to like, for engineering and finance teams to like really think about.
Right. And who, how do you find, so I've got this embedded in the system, I'm collecting a bunch of data. What do you find is the typical engagement model are the finance teams now sort of embedding with engineering? Does engineering just sort of go, hey, I've got this until I reach a threshold, until, somebody in the CFO's office screams about a bill? Or like, what are you seeing is the interactions now between, sort of, what are we calling it now? It's not DevOps, it's sort of FinOps, I guess is the new terminology everybody's using.
Yeah. So I think there's two observations here, and really kind of surprising dynamics. With the shift to Kubernetes and the way it's being deployed in most enterprises, we do see engineering leading this a lot more than we did, say, 6, 7, 8 years ago, where it's, again, getting into like these really kind of technical decisions, maybe an example is like how we're configuring our auto scaling in a very nuanced way. Yeah. And so a lot of times they're leading the action, right? They're leading the implementation, but they're oftentimes partnered with finance to think about, efficiency over the arc of multiple quarters, or just overall spend and spend growth, and things like, percentage of compute, being run in a spot environment or on a savings plan, et cetera. So it's really that partnership that when it's really strong, it like really excels. But I do think we've seen a shift toward just more engineering engagement over time, and just engineering teams, whether it be like core infrastructure team or application engineering teams, like thinking about cost early on, right? Whether that's using a tool like Kubecost or getting these metrics in a Prometheus and then a Grafana set of dashboards, or even on kubectl having this data, like a number of different options. So that'd be like observation number one. And then observation number two is that I do think when we started the project, it was way more like kind of bill shock that like led teams to us. So I can think about some of the like early users that had like a handful had Bitcoin miners installed in their clusters, and like, spent way more than they expected, or like let a, like GPU cluster run over the weekend at like, totally scaled out when they didn't expect to. And like there was a reaction to that of, we never want that to happen. I think that has transitioned more to, hey, we don't feel like we have the observability we need. We think we can be a lot more effective and accountable as an organization when we have this awareness. And we also think we can just make a lot of better decisions, right, when we have this data in real time. I think that's like where we've been over the last, call it 18 months. But now starting to see this even further shift, which is, and I think it's, like pretty closely tied to the like economic environment, which is, hey, before I bet really big on Kubernetes, I just want to get this observability in place, right? Because I now am coming in a little bit more cautious. And I know that if I don't have, visibility into my spend, and I don't have any sort of guardrails or governance solutions, it could be really costly to me, right? So I think just more shifting earlier in the Kubernetes journey where teams are becoming aware of this and being thoughtful about it.
Yeah, and that was you sort of answered my next question. I was curious as to what the progress was, and I think what you were talking about, I saw quite a bit when I was at Red Hat, and when we were running some of the online versions of Kubernetes that we did. We had to kick out a lot of Bitcoin miners after so many days, and stuff like that. I'm curious, on the side of the house. So there's always the sort of quote unquote oh shit moments where you, like you said, you get the big bill. Are you seeing now that you're seeing more people that are kind of making it part of good hygiene, do those tend to be, teams that are aligned to say digital products where, they have to be conscious of cost because it impacts, their profitability? Or are you seeing it with IT groups who, are now just sort of like, hey, we're in the cloud, we need to kind of figure out how much stuff costs? Or is it kind of a blend of different kinds of teams running Kubernetes?
Yeah, so it's really interesting, and I think there's another point on the climate that I think is influencing this. So we see it across like a wide range of teams and verticals, industries, et cetera. But I do think that there's a really big correlation with if you as a team have done this before, i.e., you've stood up Kubernetes infrastructure or you've managed Kubernetes infrastructure before. If you join a DevOps team that's like much earlier in their journey, we see that whether it's a Eng manager or senior DevOps engineer, raising their hand and saying we definitely need to think about this early on, because if we think about it much later, it can be as a result of a massive shock and scare that could just be unnecessary. And I think that's just becoming more common, right? Because we're very fortunate to have more and more, really great operators that have had kind of hands-on, experience with Kubernetes now that we're, 7 or 8 years into the journey.
Yeah.
But then I think there's this other piece that's happening with the economic, backdrop changing. And by that, I mean, interest rates going up, capital becoming a little bit less available, is we see teams kind of accelerate their journey on cost management, life cycle, if you will. We used to see teams very regularly start with, I just want to get visibility in place. I just want to start creating transparency across my organization. And oftentimes that leads to great benefits in and of itself, but still they're in kind of no rush typically to go. They were in no rush commonly to go to the next phase, which is, okay, now that I have kind of eyes and ears on my spend, now I want to really think about optimizing this or dialing this in, right? And oftentimes we're seeing more teams want to get much faster to that phase too, right? Yeah. And Kubecost itself will go in and look at your infrastructure, your containers, everything in your environment, and tell you opportunities to reduce spend. Oftentimes it's 50% or even more of Kubernetes spend, and we just see teams being much more enticed by that. Now versus say even 6 months ago.
Yeah, no, you bring up an interesting point. When the last sort of economic crash happened, and it was all the housing crisis and so forth that hit in 2008, there was a huge push at the time to not cut back on IT, but figure out, how do we do that? And it was this, at the time, huge ramp up of using VMware and virtualization, right? So they got rid of a lot of unused capacity and compute and those sort of things. You don't really have that silver bullet these days in cloud, which, kind of pushes itself towards what you guys do, which is, okay, I'm going to be in cloud. I'm already virtualized. How do I be really efficient with it? So yeah, I have to imagine you guys are probably going to start getting a lot more phone calls, just because of the nature of what's going on and people going, hey, I don't know if we're doing a good job of spending, but we need to get some eyes on this stuff. So yeah, I think, the timing is probably really interesting, especially after the pandemic where, people, had to sort of shift a whole ton of things to the cloud because, they couldn't get in their data center. I mean, there's a whole lot of kind of, this happened and this happened. So yeah, you bringing that up, I think is, history tends to repeat itself in technology. It's just, it's a different view of things. So that's very, very cool. Help our audience out a little bit. What are some of the kind of the common things that you guys see that are flagged as problem areas, areas where they can be more efficient, mistakes that they make? What's the top 5 things that your tool, your system, your recommendations are going to tell people about their Kubernetes environments that you see day in and day out?
Oh yeah, great question. So one is the Kubecost community version. You can installed, and it'll actually just, tell you within, minutes of like, data being generated to like start giving you this insight, these insights. And I would say it really varies pretty wildly. And there's some common patterns in terms of like, how many teams or applications, or like, is it a central team manage your like, Kubernetes infrastructure, or is it, spread across different teams? But I would say like commonly when we start working with teams, it's, there'll be 5 to 6 like really obvious things. And again, these tend to be teams that are like more, medium and large size enterprises. But it could be anything from like really, looking closely at like auto scaling. If teams are already using like a cluster auto scaling like solution, for example, it's really common where your environments will auto scale up, generally efficiently, but they may not auto scale down like you would expect. And this could be for various reasons, like you have workloads that are using local storage, or don't have pod disruption budgets that are preventing like scale downs from happening as you would expect. So there's a whole like class of things there around like auto scaling not driving the efficiency it could. I think there's also at the application layer, like actually right sizing the resources that are provisioned, given the like context of that application. So we help teams think about, if something is like an HA or critical workload, you're going to give it different priority. You're going to, probably provision excess resources to it, just in case there is a shift in user behavior and it has an increase, amount of needs. Whereas if it's like a dev or a staging cluster, you're going to think about that really differently, right? So like getting those, applications right size allows you to then bin pack them much more efficiently. So, thinking about where you put them in your infrastructure, what type of machines, what AZs, regions, clusters, et cetera. There's a lot of stuff there. And even there, that could be, down to like the chipset level, like what is right for your, set of applications. Yeah. And then, let's see, then I think there can be some really specialized situations and say a pretty long tail, but like, the way you're provisioning storage is driving you to like radically overspend, or the way that you have like configured your applications and how they talk to like gateways or like, egress and communicate with each other could be driving unnecessary spend. I would say, there's, I believe, around 15 different insights in total. And this is where I think like having it be very contextually aware and like, again, provide data in real time can be super, super powerful.
Right. Yeah, no, it's good stuff. And the nice thing is, it's, there's a community around this as well. It's not just, the insights that you guys get from, your customers and the early customers, but it's sort of insights coming from all over the place. And cost tends to be one of those things that like, you never believe how much something might cost you in IT until, things get weird. And, so you guys are probably seeing stuff from all sorts of interesting angles, I imagine.
Yeah, we've seen, tons and tons of different stories and, ways that this can, go right. And also, ways that it can, kind of go sideways when, again, these kind of like guardrails or governance solutions aren't in place. Right. But it also just feels like, again, that this ecosystem is rapidly changing. I think if you look at Kubernetes itself, it really like lends itself to doing this, in my view, of like, you now have infrastructure as code, you now have like all of this structured metadata, you have all these like open source interoperable observability solutions, again, like a Prometheus, where just increasingly engineering and infrastructure teams are able to like do things that weren't possible before, right? And just make increasingly intelligent decisions about cost and availability and, performance in real time.
Yep. Good stuff. So for folks listening and they go, okay, we're running Kubernetes, those guys seem to know what they're talking about. What's the best way for folks to engage with Kubecost, engage with the software, start making better sort of financial decisions for their Kubernetes?
Yeah, I think a couple different paths. One, we've got like an open Slack community that's just like accessible via kubecost.com. Can come join there and just start asking questions or start engaging with others. And then two is like Kubecost community versions available for free, always for free. You can actually just start to see insights. And again, like if you're using Prometheus observability stack, et cetera, you can actually integrate it with your existing observability. So I think those are two ways to get started that you can do quickly, and are available to anybody running Kubernetes or anybody just interested in these concepts.
Yeah, good stuff. Webb, thank you so much for the time today. It's good to dig into this part of the sort of Kubernetes ecosystem that obviously has a kind of immediate impact on the bottom line for people, whether it's their budgets or their the cost of their products or hopefully kind of the success of their projects. So thank you for the time today. Thank you for kind of sharing your expertise and obviously kickstarting the project and keeping it going. Folks, with that, we want to thank Webb for his time on behalf of Aaron and I. Thanks everybody for listening. Thanks for telling a friend. Thanks for helping us grow the community. Hope everybody's summer is going well. And with that, we'll wrap it up and we'll talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.